All right, well, we're going to push past some of that stuff we did in 2.6, and we're going to give some stuff here in 2.7. Now, ultimately, the material that's in this next following day is really no different than what we've talked about in the past. The ones that we saw before were all single step. We're just going to talk about how do we deal with a multi-step one. Now, making sure that we're still keeping in mind that when we do things about multiplication / division by a negative, we need to be looking for those for the switcheroo case. When should we switch the sign? And that's going to be kind of in the back of our mind when we start talking about these multi-step inequalities. Now, they get undone the same exact way that you normally would do an equal sign. And to undo a multi-step one, you really have to make some serious choices. You have to make some choices about what do you move first. You're kind of thinking, what's the first thing that's got to go? What's the second thing that's got to go? And so forth down the line. Now, I think that one of the easiest ways to remember about which numbers need to be moved from one side to the other and which ones should go first really boils down to going back to something that we've seen a lot of in the past, and that is PEMDAS. Now, you're probably thinking, PEMDAS is really only useful for figuring out how to come up with a number in terms of its order of operations. Now, you're absolutely right. If you think about it going down the line, it's an order of operations way of thinking about it. But if you think about PEMDAS in reverse, going in this direction, it tells you exactly which functions to use in which specific order. If you think about it going in reverse, it's basically saying that additions and subtractions are the first thing you should deal with, and multiplications and divisions are the second thing you should deal with, whereas exponentials and parentheses are last. And that's the last concept. Now, this will get you through about 90% of the time. Once in a while, we run into some funky stuff where we've got to do some combining like terms. But ultimately, it boils down this basic idea. Now, when I look at a question like this very first one, I know that the B is the part that I'm really trying to get all by itself. And I'm just going to kind of, I'm going to try and zoom in on this just a little bit so you can see what I'm trying to say. So you're really trying to get that B value all by itself. Now, what you're staring at is two different kinds of things that need to move. You've got this 4 and you've got this 8. And now you're like, what are my choices? What do I got to move? Well, PEMDAS in reverse tells you exactly which one to move first. It says move the additions and the subtractions first. Well, this is a subtracting 4 concept, and it makes sense that that should be the first one to be moved off. So opposite of subtracting 4 would be to add 4 to both sides, and I'd end up with 5 is less than B over 8. And now I've gotten rid of the 4. I made that choice that had to go first. And the 8 is the next level of stuff that needs to be moved. Since it's a division problem, I would take care of that division problem by multiplying each side by 8. And I'd be with this B, and there's 40 on the other side. Now, I am not going to switch the sign on that because the 8 that I multiplied by was a positive. We only switch when it's a negative that we multiply or divide by. But this guy will switch in one instance because we want to put the B on the left-hand side, and we want to keep this thing eating or pointing at the same thing. See, it's pointing at the 40. If I put the 40 over there, I got to keep it pointing at the 40. And the answer here would be B is greater than 40. All right? So in terms of multi-steps, the only thing really different that we're going to be dealing with is the fact that you have to make some choices about what things need to move, all right? So maybe underline the piece that you got to get isolated. You're like, okay, I got to get the C by itself. Who do I need to move? Well, based on PEMDAS, the one that's being added or subtracted is the 5. Now, that's a positive 5. So opposite of it would be a negative 5 on both sides to get rid of it. And I'd end up with negative 2 is C is less than 4. Now you're looking at it going, okay, PEMDAS, the next level up would be to deal with the multiplication. And to get rid of it, I would use division of a negative. And ultimately, I would switch the sign because of the switch case that's being used in that particular regard. So use PEMDAS in reverse to help you decide how to move things from one side to the other. Now, as I said, sometimes you might run into things where you got to like do a little bit of work ahead of time before you start moving anything around at all. You got a number out here outside of this this binomial. It'd probably be best to distribute it and take a look at what you end up getting inside there. So 2f minus 8 would be just that guy multiplied through, minus 3f is less than 18. And again, if stuff on the same side can be pulled together and be simplified a little bit, why the heck not? Let's not put those things together. 2f's and negative 3f's would be negative 1f together. Minus 8 is less than or equal to 18. And now this question is no different than the ones that appeared before. What am I going to get rid of first? Well, PEMDAS in reverse says I should get rid of the addition subtractions first before I deal with the multiplication. So add 8 to both sides. Negative 1f is less than or equal to 26. And then I would get rid of the multiplication with division next. And in that process, I'm dividing by a negative, so the answer must switch signs to a negative 26 because a positive divided by a negative is a negative. Okay? So when they make these complicated at the beginning, distribute through and combine terms before you start making those choices of what's going to move to which side. Even if it doesn't have parentheses, sometimes moving stuff around and combining stuff makes a lot of sense. Now, these two are on the same side. Well, let's just get those two together. 3x minus 9 is less than 3x plus 2. And if we've got variables on both sides, it makes sense that maybe they should be shifted to the same side. And something bizarre happens on this one. You end up getting a cancellation on both sides, and you end up with negative 9 is less than 2. Now, when you lose a variable like this, you're going to run into one of two cases. You're going to either run into the case of it being no solution at all, or is it going to be every solution that you ever possibly could think about is going to be the choice? Now, I like to write it like this because I ask myself, is this really a true or false statement all the time or none of the time? And is negative 9 less than 2 all the time? And the answer to that is that happens all the time. So it would be an all solution case because every single thing would work. So basically remember that if it turns out that you lose a variable or lose both variables, that you want to look at it either being an all solution or a no solution case. Now, here's some ideas. Both of these two questions, A and B, that are down here at the bottom, are similar to ones that we discussed just up above. And I'm going to give you a little bit of time. There's going to be a little blank space here where you can pause the video, try the questions out, pause the video and try them out, and then ultimately you can come back and see the solutions in just a moment and see whether or not you're on the right path. So give that video a pause. And I know it's like magic. Those things just appeared a few seconds later, but that's me doing the work in the background. And let's just kind of take a look at how well your solutions turned out. So in like this first one, letter A, I distributed through, wrote that individual value, then used my PEMDAS in reverse. Again, thinking about over here on the side, please excuse my dear Aunt Sally, and working this guy backwards that the additions and subtractions should go first. And then subtracting the 15, not going to switch my sign because it's subtraction. Then I end up dividing by negative 6. And as soon as I divide by negative 6, dividing by a negative triggers the flipping of the sign that we discussed in the previous unit and end up reducing my fraction to its lowest terms of a negative 1/2. Now on the B side of this one, I moved the 8 over to the other side to start with, to try and get variables on the same side. That seems to make sense. Our numbers on one side, letters on the other. And ultimately got a negative 5e plus 13 is greater than negative 7. Again, I subtracted 13. That's not going to switch the sign. But then when I divide by this negative 5, it is going to switch the sign, and a negative divided by a negative is going to be a positive. All right? So go slow. Take it one step at a time. They're multi-step on purpose, and that's because they take more steps than just one. And you've got to be able to think about what comes first and what comes next. Now, if we're going to move on to this next piece, sometimes we look at word problems and our brain says, oh goodness, it's got words, but it ultimately is still a math problem. It's not that bad. You just got to decipher some of the information that's going on here. Now, your cell phone plan only costs $15 per month. Well, you wish it did. That's probably your portion that you have to pay your parents, but they're taking care of you for it. But this one only includes 1 gigabyte of data, which would probably kill most of you in about an hour. If the phone usage during the month is over a gigabyte and you end up going over that particular plan, they charge you an additional $12.50. This is what a lot of you guys move away from, trying to get to an unlimited plan, but I work on a plan like this for my own family. We only get 4 gigs for the whole family, and if you go above and beyond that, then it ultimately makes you cost for it. And here's the deal, and the reason behind it is I'm trying not to exceed a certain amount of dollar amount for our phones. So $50 is the maximum amount I'm willing to spend. It's an easy way to try and organize or balance your budget sheet. How many gigs can you use without exceeding your actual limit? Now, I kind of underlined some things as I went through this word problem, kind of thinking, oh, these are really important things. Now, I'm going to work it kind of on a backwards way of thinking about this. First off, I think the exceeding $50 is a pretty simple thing to deal with. First off, I know that whatever I end up doing on the left-hand side, it's got to be less than or equal to $50. I can't go over that amount. Whatever it's going to be, it's got to be less than that $50. So that's what this part over here is exceeding. And if you see those, make sure that you pay attention. And that's like your at least or at most statement. This is really saying not to exceed means at most it's going to be $50. So it's got to be less than. It's got to be that backwards concept. Now, you're going to get automatically charged $15 no matter what. So it's going to be $15 right out of the gate. But you might get charged an additional amount on top of that if you go over the specific amount. Now, here's where we're going to have to try and figure out what to put here in the middle. Now, the part that's going to go here in the middle, we have to really think about for a second. We're going to have to say, first off, that whatever variable we choose, we can't say that there were negative gigs. That doesn't make any sense. So first off, we're going to have to say that it's greater than or equal to 0. Okay? And what that value is that we're going to think about. We know we're going to get charged $12.50 for every single amount, but we're only going to get charged for every additional one above the original one that we already got. So what I want to say is you can't just put X in here, because if you put in X and you use the number 1, then you wouldn't be charged just $15. You'd be charged $15 plus the $12.50. So this guy right here has to be 1 shorter than the number of gigs that they say. So like they say 3 gigs is how many you used. Well, ultimately, the first one was for $15, but the other 2 were the ones that were going to get charged $12.50. That's what's going to end up happening. So instead of putting the number 3 in here, we would end up putting in X minus 1. We're going to do 1 less than the number of gigs that come out on the bill. Okay, you get a bill that says 5 gigs, it's going to be 4 that you're going to get charged for, because the first one only cost you $15. Okay, does that make sense, kind of how I had to think about that? Now, this problem looks exactly like stuff that we saw up above in the original question. So maybe this parenthesis stuff, we could distribute across it so that we could see what it looks like. 15 plus 12.5x minus 12.5 is less than or equal to 50. And we've got $2.50. Sorry, we'll make it that way. Ooh, these two probably could be combined on the same side. So if I take $12.50 away from $15, I'd be left with $2.50 plus 12.5 times x is less than or equal to 50. And now I go to my reverse PEMDAS to try and figure out how to move some stuff around and solve for this x. We're trying to figure out what's the maximum we can get to before we're over the $50 mark. Well, let's subtract $2.50 from each side. And that'll get rid of it here because we got to get rid of subtraction or addition first. 12.5x is less than or equal to. Now, if I subtracted $2.50 from this, I'd be at $47.50. Check my math on that. Make sure that that works. And $2 from it would be 48, another 50 cents. That seems reasonable. And then I would divide by 12.5 on each side. And this is where you would grab a small calculator and figure out what this decimal is going to turn out to. So let's see here. 4750 divided by 1250. And let's see how many gigs we can actually get. It's got to be less than 4750, a certain amount. Let's see here, 1250. And I'd be looking at 3.8 gigs is the maximum amount that I would be able to see on my bill before it would exceed the $50 mark. And you might put in like some kind of thing in your Verizon account that says, this is my mark when it's going to get shut off, and ultimately would go to, data saving or some kind of plan like that. Now, the biggest problem that most people have when it comes to word problems is taking something that's written in words like this and deciphering each of these individual components and writing some algebra that's out of it. What you want to do is get in a good habit of how to find those pieces of important information and slowly but surely build your argument in terms of what the algebraic expression needs to look like. You know how to do this algebra part. Don't let this step right here of building a good plan actually hold you up in doing some math that are word problems. So give those guys a try and really ultimately write a good expression and try it out. If you struggle with this, that's when you have those days when you see us. Stop us, make us talk you through it so you can see all the important points. Use colored pencils to maybe help figure out what the important pieces are, and then you'll get better at it. There's no way to get better at it other than just practice. So keep practicing at home, and more importantly, just keep asking questions when you're here. Good to see you guys, and catch you in class.